5.4, Introduction to Inverse Trig Functions. So it's important to note that the x values below represent an angle, and therefore we need to, and the function returns the corresponding sine, cosine, and tangent y value. So these are the original basic trig functions. We have sine, cosine, and tangent. And we're going to restrict the domain that you see in the bolded blue so that when we graph the inverse of these functions, they are still functions. So my first restricted domain for sine is going to be negative pi over 2 to pi over 2. And the range of this is negative 1 to positive 1. For cosine, we have 0 to pi and negative 1 to 1. And then tangent is very similar to sine, however, we have vertical asymptotes, so we're going to go from negative pi over 2 to 2, but we're not going to include negative pi over 2 and 2, just everything between it. And then the range for this one is all real numbers, negative infinity to infinity. So down below you see the inverse functions, or the inverses of the given function. So we have sine to the negative 1, so the inverse of sine, which is also known as arc sine. And then you see the inverse of cosine, arc cosine, and then inverse of tan is arc tan. So these two names represent the same thing. They're just two different notations, two different ways to write it. So we're actually going to find the domain and range of these. And similar to most inverses that you know, the domain and range are going to flip places. So our inverse of sine is negative 1 to 1 for its domain, and its range is negative pi over 2 to pi over 2. For the arc cosine, we have a domain of negative 1 to 1 and a range of 0 to pi. And then for tangent, our domain is now all real numbers, and our range is negative pi over 2 to pi over 2. Again with parentheses because now we have horizontal asymptotes. So down below you see the three triangles, and these restrictions can also be expressed in reference to our right triangle trig. So notice that for sine, we are in quadrants 1 and 4. For cosine, 1 and 2. And for tangent, also 1 and 4. So instead of having all four quadrants, we restrict them just like we did the inverse and the basic trig functions. Okay, so now I want you to use the table of special values, so that half sheet given to you in class or in your notes section from the previous part of Chapter 5, to give the value of each expression. And so first we're going to start in radians. So I want to go sine inverse of 1/2. So since I'm doing the inverse of sine now, I'm going to start on the right side of my chart at the value 1/2 for sine, and then go to the left to the angle value in radians, and in that case we get pi over 6. Now, it's important to note that for these values, a through f, there's only one answer. Why is that? Well, we just talked about the restricted domain. Cosine is in 1 and 2, and then sine and tangent are in 1 and 4. So we have to make sure these values fall into those quadrants. So for example, B, cosine of negative pi over 2 over 2. I'm sorry, root 2 over 2. So I'm going to go to cosine to root 2 over 2, and I get pi over 4. Now, pi over 4 is in the first quadrant, However, since our value of root 2 over 2 is negative, we know that that's actually going to be, or cosine is going to be negative in quadrant 2. So the pi over 4 is useful because this is our reference angle. So to find that value, since we know it's going to be in quadrant 2, to find that we do pi minus pi over 4. And when you solve this, you need to find a common denominator of 4. So your value of the cosine inverse of negative root 2 over 2 is 3 pi over 4. Okay, the tan inverse of 1. So on my chart, I'm going to go to tangent of 1, and again to negative 4. I mean pi over 4. So pi over 4 lies within the first and fourth quadrant, so this is our value, our angle. So we have pi over 4. It's important to note that we get 1 because tangent is y divided by x, or sine divided by cosine, so that means that x equals y in this case. And when you look at your chart, if you go tangent of 1 and you go to the left under cosine and sine, they're both root 2 over 2. Therefore, they're equal to each other, so that's where we get the tangent of positive 1. Okay, so now we're going to do the arc cosine of negative 1, which is the cosine inverse. So I go to my cosine chart on the right, and I go down to positive 1, and I know that my value in radians is 0 when I go all the way over to the left. So this one we have to think about a little bit differently. If cosine of theta gives me 1 at 0 degrees. So if we know at 0 degrees, right here, then we have cosine of positive 1, or cosine of theta at positive 1, then that means that directly across from that, we're going to have negative 1. So the cosine theta of negative 1 means that to find the theta, we have to do the arc cosine, or the inverse. So we go backwards, and we're trying to find that radian value, so we have pi. So right here on the graph is where pi lies. All right, for E, we have sine inverse of root 3 over 2. So I go to the sine column on my chart, to root 3 over 2, and I get pi over 3. But that's positive, so we know that this is our reference angle, pi over 3. Now sine is negative, which means if the sine restrictions are in the first and fourth quadrant, then we must be in quadrant 4 for sine to be negative. Now, we don't have to take 2 pi and subtract we don't have to subtract pi over 3 from 2 pi because we're allowed to have those negative values in that restricted domain for sine. So going in the other direction is all we need to note. Instead of going the positive direction of pi over 3, we're going to actually go the negative direction of pi over 3, which lands you in quadrant 4. Then for tangent of inverse of negative 1, under tangent 1 gives me pi over 4. So that's going to be my reference angle. Let's see if I can squeeze that in. So pi over 4, but since it's negative, we have to go the other direction, which again, just like the one we just did, puts you in quadrant 4, making tangent negative, because we know in quadrant 1, tangent's positive because they're all positive in quadrant 1. So we just go the opposite direction and end at negative pi over 4. Okay, so the next part of this is just using our calculator to approximate and to kind of see if we are doing the calculator steps correctly. So When you do sine inverse, so you have to use second sine of negative 0.8, you get about negative 0.927. So go ahead and do that and make sure you're getting what I'm getting. Now the arc cosine of 3 is actually going to give you an error. It's not defined, meaning you can't do that. Well, why is that? Well, if we consider the triangle, if we're using theta, then cosine is adjacent over hypotenuse. So if cosine equals 3, then to find that degree, it's not possible, because that means that we have adjacent, which is 3x, and our hypotenuse, which is x, and you can't have the adjacent side be greater than the hypotenuse. So that's why it's undefined. So whenever you get that error in your calculator, this is the y. And then for tangent, it's sine over cosine, so we can have a value of 3, so we get about 1.107. Okay, so now we're going to think about this in degrees. So inverse trig functions can also be used to find angle in degrees. What will the range restrictions be when working in degrees? Is there a change to the domain of these functions when transitioning to degrees? And the answer is no, there's no change. So there's no change for the domain, making them what they were before. Negative 1 to 1, negative 1 to 1, and negative infinity to negative infinity. But we know that before we were using pi and pi over 2, so yes, that's going to be a change, and we're just going to put it in degree mode. So our range for the inverse of sine is going to be negative 90 degrees to 90 degrees. Our range for cosine is going to be 0 to 180 degrees. And then our range for the arctan is going to be negative 90 degrees to 90, but again, we're not going to include them, so we're using parentheses. So we're going to do the same thing, same list of values, A through F, that we just worked with, but we're just going to put them in degrees. So you follow the same steps. You go to your table, sine of 1/2, and you go to the left to degrees, and you get 30 degrees. So now with B, same thing. It's still going to be in quadrant 2, just like before, but our reference angle is not pi over 4 now. It's 45. So essentially, to find the value, we do 180 minus 45, which lands us at 135, which is in quadrant 2. And then the inverse of tangent at 1, we said was pi over 4, so this makes it 45 degrees. For letter D, arc cosine of negative 1, we said was pi, which is 180 degrees. And then for E, we said that we had to first find the reference angle, which we said was pi over 3, which is 60 degrees. And we know it's still in quadrant 4. So for us to be in quadrant 4 and use our 60, we're going to do, we're just going to go, we could go 360 minus 60, but again, we're allowed to be negative, and negative 60 falls into that restricted domain that we just set, range that we just set, so we can write negative 60 degrees. And then for tangent of negative 1, our reference angle was 45 degrees. Quadrant 4, so just like the one we just did, it's going to be negative 45 degrees. Okay, so now we're going to go back to reference angles a little bit. And if you recall, a given angle theta in standard position is its reference angle theta is the acute angle formed by the terminal side of theta and the x-axis. So you probably remember these graphs. You've seen them before in your notes. So what we're going to do is now we're going to find all angles between 0 and 360. So make sure you're in degree mode. So I can use my chart because root 2 over 2 is in our chart. So if we go to cosine theta, then we go down to that, to root 2 over 2, and we get 45. So we state that our reference angle is 45 degrees. Okay, since this is negative, and now we are going to be between 0 and 360, so where's cosine negative? Cosine is negative in the second quadrant and the third. So we're going to find two values, one in the second, one in the third. So to find theta in the, let's say this one is going to be in the second quadrant, we take 180 and we subtract 45 from it, and we get 135. So that's our first value. And for the third quadrant, we take 180 and we add 45. So we get 225. So this is our second value. Now, for letters B through G, the table of values doesn't help us. We actually need the calculator to find the reference angle, because if you notice, those decimals are not the exact values we have on our chart. Okay? So the first thing you need to do to find that reference angle is do the trig inverse function and then determine where it's going to lie and then find the angles. So let's go ahead and do one. So in my calculator, to find the reference angle, I'm going to do the sine inverse of 0.9659, and I get about 75 degrees. Now, sine is positive, which means it's going to be in quadrants 1 and 2. And the lucky thing about this is that for quadrant 1, our reference angle 75 is the first value because 75 degrees is in quadrant 1. So then to find our second theta, we're going to do 180 minus 75, which puts us at 105, which we know is in the second quadrant. Okay, so for cosine, same steps. To find our reference angle, we do the inverse cosine in our calculators of 0.2924, and we get about 73 degrees. Well, this value, cosine theta, since this is positive, tells us we are going to be in quadrants 1 and 4. Again, 73 is in quadrant 1, so our reference angle is one of our angles. And any time you're in quadrant 1, your reference angles, since they're between 0 and 90, they are one of your values that you're looking for. But that's only if you need quadrant 1. So then our second angle that satisfies this function, we have to then be in quadrant 4. So to do that, we're going to do 360 minus 73 degrees, which gives us 287 degrees. Okay, so let's do the last couple. So for sine theta of negative 0.7660, our reference angle is going to be sine inverse of negative 0.7660, which equals about 50. I was looking at the other problem. Now, 50 is in quadrant 1, but sine negative is in quadrants 3 and 4, so that 50 doesn't help us, other than just being the reference angle. So theta then in quadrant 3 would have to be 180, and we add 50 to it. So 230 is our first angle. And our second is going to be 360 minus 50, which puts us in the fourth quadrant at 310. And it's always good to double check to make sure that even though you're just adding and subtracting with 180 and 360, it's really good to make sure those values that you get afterwards truly do fall in the quadrant you're saying they do. Okay, so our first tangent, 1, so again, tan inverse of 0.4773 equals about 25.5 degrees. If you put 26, that's fine. Now, tangent is positive because this value is positive in the first and the third. So we have our first one, right? That's our reference angle, which is also the value we're looking for. And our second angle is going to be 180 plus our reference angle, which puts us in quadrant 3 at 205.5 degrees. Go ahead and try the second two on your own and see if you get what I get. So our first one, we found a reference angle, I forgot to write it, of 35 degrees. Now cosine's negative here, which puts us in the second and third quadrants. So I added to 180 and I subtracted to 180 to find my two angles. And then for tangent, we have a negative value. After doing the inverse of tangent in our calculators, I got about 54 degrees. So since the initial value is negative, that puts us in our second and fourth quadrant. So I subtract from 180 to get my second quadrant, and then from 360 I also subtract to be put in my fourth quadrant.